Okay, so we're starting on Chapter 4, which is all about just introducing you to triangles, and then we're going to move on to looking at congruent triangles, how we tell whether they are congruent or not. So Section 4.1 is all about classifying triangles. So before we go straight into classifying, I just want to review with you real quick the different parts of triangles. So if you look here, we have this triangle. If we were naming this triangle, we would call it triangle ABC. So you can use the little triangle symbol and then the three, those are called vertices of that triangle. Alright, so first let's look at the sides of the triangle. The three sides of this triangle will be AB. And make sure you put a line on top of that with no arrows. That means it's a segment, it has definite endpoints. So segment AB, segment BC, and segment AC. Those are our three sides of the triangles. Next we have the vertices of the triangle. The vertices of a triangle are just the points. And the vertices of any polygon is just the points of that polygon. So the vertices here will be A, B, and C. Those are the three vertices, point A, point B, and point C. And next we have the angles of the triangle. So our angles here would be angle A, or a way to name that with 3 points, which we'll have to do a lot in this chapter, would be, for instance, BAC. So you're going to have to be able to name it with either just one or with all 3 points. The next one would be angle B or angle ABC. That would be another way to name that one. And then the last one would be angle C or angle ACB. So those would be the 3 sides, the 3 vertices, and the 3 angles of the following triangle. So if you were given this, you should be able to name 3 for each. Alright, so first thing we're going to look at is classifying triangles by their angles. So the first of which, and I understand that most of this is probably review for you, but it's worth going into a little bit. The first of which is an acute. An acute triangle has 3 acute angles. So if all the angles in a triangle are acute, that is an acute angle. That's the classification by its angles. For instance, 60, 61, and 59. Since all of those angles are acute, that is an acute triangle. The next one we have is obtuse. An obtuse triangle has 1 obtuse angle. So if you have a triangle that even has 1 obtuse angle, it's automatically an obtuse angle, an obtuse triangle. So for instance here, let's say that this angle is 120, and this one is 29, and this one is 31. That would be an obtuse triangle. Even though these other 2 are acute, that's still an obtuse triangle because it has 1 obtuse angle. The next one would be right. A right triangle has 1 right angle, like obtuse has 1 right angle. And again, it just has to have 1. So these other 2 angles, for instance, will both be acute. But that doesn't mean it's an acute triangle. Since it has that right angle here, it is a right triangle. And then the last one we have is equiangular. An equiangular triangle is a triangle where all angles are congruent. They're all the same. That is an equiangular. Alright. And I want to go a step further with this one. If we know that the sum of a triangle has to be 180 degrees, and all 3 of these angles measure the same, they all add up to 180, so that means that each one of these angles here has to be 180 divided by 3, since they're all the same. So if you work that out, that's 60 degrees. So every angle in an equiangular triangle measures 60 degrees. That's worth noting. Alright, so let's look at the following example. We want to classify the given triangles by its angles only. So let's look at the first one, triangle QSR. Triangle QSR is this triangle in red here. It's got a right angle, so that means that QSR is a right triangle. That's classifying by its angles. That is a right triangle. Let's look at the next one. We'll look at triangle PQR. That is this big blue triangle, the whole thing. So we've got an angle of 45 here, an angle of 31 here. We need to know what angle Q is, what that whole entire angle is. So it is 45 plus 59. So if you work that out, that'll be 104. So since that's an obtuse angle, we know that triangle PQR is an obtuse triangle. All right, let's look at the last one. Let's look at that green triangle, triangle PSQ. PSQ, that is this green one here. So if you see, we've got two angles of 45. We don't know what this angle is, but we know it's supplementary to that 90-degree angle over here. So that means that this angle also has to be 90. So triangle PSQ is also a right triangle. So that is classifying triangles by their angles. So now let's look at classifying triangles by their sides. There are three ways to classify a triangle by its sides. The first of which is equilateral. In equilateral triangle, all three sides are congruent. That is equilateral. All three sides are congruent. And again, I understand that most of this is review, but we're just refreshing your memory a little bit. So that is an equilateral triangle. Something neat about an equilateral triangle, if its sides are all congruent, its angles are going to turn out to be congruent too. So it's equilateral and equiangular. The next thing is an isosceles triangle. In an isosceles triangle, two sides are congruent. So just two sides are congruent in an isosceles. Whoops. So that's an isosceles triangle. Two sides are congruent. And then the last one we have is scalene. In a scalene triangle, no sides are congruent. So all the sides are different in a scalene triangle. All right, so we got equilateral, isosceles, and scalene. So now we're going to look at classifying these triangles by their sides. So let's read the information we have. We have M is the midpoint of JL. So if M is the midpoint of JL, this is the midpoint of that segment, we know that this length is congruent to this one. All right, so those have to be the same length. So what we want to do here is classify triangle JKM as equilateral, isosceles, or scalene. So I'm going to just trace that triangle JKM, that's right here. So we know, first of all, that these two sides are congruent. But what I want to do is I actually want to find out the length of JM, just so I can make sure it's not 0.75. Because if it's 0.75, then not only is this triangle isosceles, but all three sides would be congruent. So it would be equilateral. So we want to check that. So we know that JM is just going to be 1.5 divided by 2, because we were told that M was the midpoint. So if you do 1.5 divided by 2, sure enough, you get 0.75, sorry. So you get 0.75 here. So since that one's 0.75, we also know that this is 0.75. So since all three sides are 0.75, this has to be an equilateral triangle. Okay, so that's equilateral. Let's do one more real quick. Let's look at triangle JKL and classify it. So if you look at JKL, that's the whole triangle here. We've got a side of 0.75, a side of 1.3, and a side of 1.5. So since none of the sides are the same, that would be scalene, the scalene triangle. All right? So let's look at a few examples involving a little bit of algebra and using the information we just learned today. So here we want to find the measure of the sides of the isosceles triangle ABC. So we're told this one is isosceles, and we're given what two sides of this triangle are congruent, these two specifically. So since we know those sides are congruent, we know that 4x plus 1 has to equal 5x minus 0.5. So now we just need to work that out. If we do that, we get 1 equals x minus 0.5. So x here is just 1.5. So that is our x. Once you find your x, you were asked to find the measure of the sides. So we can plug that back in and get the measure of all three sides here. So if we do that, let's plug it back in for x for AC. So that'd be 4 times 1.5 plus 1. So if you work that out, that is 6 plus 1. So that side length is 7. Since those two sides are congruent, I automatically know that this side is also 7. And so now we just need to find out the length of AB. So if we plug that in, we get 9 times 1.5 minus 1. And when you work that out, we get 13.5 minus 1, which is 12.5. So that would be the length of AB. So that's how we use the fact that this was an isosceles triangle to find all of its lengths using algebra. So let's look at the last one real quick. So this one says find the measures of the sides of an equilateral triangle. Remember, equilateral means all sides are congruent. So each one of these measures exactly the same. So all three are congruent, but when we solve for y, we're only going to want to set 2 equal to one another. Okay, we're not going to set all 3 equal to one another. That doesn't make sense. So I'm going to pick the ones that have the smallest numbers, just because I would rather work with small numbers any day than big numbers. It makes my job easier. So we're going to do 2y plus 5 equals 3y minus 3. And we know they're equal because that's an equilateral triangle. All sides are congruent. So if we solve this, we get 5 equals y minus 3. So therefore, y equals 8. Now again, that's our variable. What we want to do is find the sides. Make sure when you're doing these types of problems that you read the directions really carefully and understand what it's asking you. So if I want to find the sides, I'm going to plug that in. We're going to get 2 times 8 plus 5. So that would be 16 plus 5, which is 21. All right? And that is going to be every side of that triangle because it's equilateral. So FG equals GH equals FH, and they are all 21. So that would be the answer to that problem. Every single one of those sides is 21. All right, what I want you to do now is pause this. See if you can do these problems on your own. And then when you unpause it, I'll put the answers up for that. All right, so here are the answers to those. Hopefully you got all those right. If not, come into class tomorrow and we will go over these. See you then.